Welcome back to my channel. This is the sixth video of the chapter Determinant of Matrix. The question is, prove that x, y, z, x square, y square, z square, and yz, zx, and xy equals 1, 1, 1, x square, y square, z square, and x cube, y cube, z cube, which is again equal to x minus y, y minus z, z minus x, and in bracket yz plus zx plus xy. Now the left hand side of the given question is this. Now multiplying by x, y, z on denominator and numerator, so that we can multiply this column 1 by x, column 2 by y, column 3 by z, because here x is missing, so multiplying by x. Here y is missing, so multiplying by y, and here z is missing, so multiplying by z. So by multiplying by x, it is x square, x cube, and xyz. Y into y is y square into y is y cube, and zx into y is xyz. Similarly, z into z, z square into z, z cube, and xy into z, that is xyz. Now taking xyz common from this R3, 1 by x xyz already here, and taking common xyz, and this xyz cancels this xyz, remaining is this. Now interchanging these two rows, we get this and this cancelled, so x square, y square, z square, 1, 1, 1, x cube, y cube, z cube. Here we need to take the negative sign, because by the property of determinant, interchanging or swapping any two adjacent rows or column changes the sign of the determinant. So here we interchange or swap these two rows, so we need to take the minus sign here, and in next step interchanging these two first and second row, we get 1, 1, 1, and x square, y square, z square, and x cube, y cube, z cube. And I have already told by the property of determinant, interchanging these two will give again minus sign, and minus will be positive, so it is positive 1, 1, 1, x square, y square, z square, and x cube, y cube, z cube. Here there are 3 1s, so subtracting 1 from 1 will give 0, and again 1 from 1 will give 0, so we can make 2 0 in this R1. So C2 minus C1, this minus this is 0 in C2, and in C3 minus C1, 1 minus 1 is also 0. So this column remains the same, and this minus this is y square minus x square, and this minus the y cube minus x cube, and z square minus x square, and z cube minus x cube. So we are near to the answer because x minus y is the same thing as y minus x with negative sign, and z minus x, z minus x. So our approach is the correct. And now expanding along R1, because here is in R1 there is maximum 0, in R2 there is no 0, in R3 there is no 0, in C1 there is no 0, in C2 there is only 1 0, in C3 there is only 1 0. The maximum 0 is in this R1. So for simplicity you have to expand along this R1, but expanding along other will also give the answer, but it is the longer process. So expanding along R1 is 1 multiplied by removing this row and column, and the remaining is this determinant of this, and this is y square minus x square, z cube minus x cube, and minus this one, z square minus x square multiplied by y cube minus x cube. Now we can take common y minus x and z minus x. Y minus x and z minus x, and remaining is y square minus x square is y minus x, y plus x. Y minus x is already taken common and leaving y plus x, and z cube minus x cube is z minus x, z square plus zx plus x square, z minus x, z square plus xz plus x square, and z minus x is again z minus x, z plus x, and y cube minus x cube is y minus x, which we have already taken common, and the remaining is y square plus xy plus x square. Y times z square is yz square, and y times zx is xyz, and y times x square is x square y, and similarly x times z square is z square x, and x times zx is zx square, and x times x square is x cube, and z times y square is zy square and minus sign, and z times xy is xyz with the negative sign, and z times x square is zx square, again the negative. X times y square is x square with a negative sign, and x times xy is x square y and negative sign here, and x times x square is x cube. Now this zx square and zx square cancels each other, and positive xyz and negative xyz cancels each other, and positive x square y and negative x square y also cancels, and finally positive x square and negative x square cancels to 0. Now the remaining is y minus x, z minus x, and yz square, z square x, minus y square z, finally minus x y square. Now y minus x, z minus x is as it is, and taking yz here, yz here, so yz taking common, remaining is this z minus y, and from here taking x common, the remaining is z square minus y square, and this as it is, taking z minus x as common, here remaining is yz, and here remaining is x times z plus y, that is xz plus xy. Now we need to convert this in ascending and cyclic order, that is, first of all x will come, and first of all there should be x and y, and finally z in this direction. First of all x minus y, then y minus z, because here is y, z minus x is the opposite direction, so y minus z, and we convert y minus x into x minus y, so negative sign will be here, and we convert z minus y into y minus z, so minus minus will be plus, and z minus x is as it is, and x will become first xy and yz and zx, xy, yz and zx.